What does good engineering look like when people you need to work with occasionally show up for work drunk? That's exactly what I've been trying to figure out for the last few months, doing research with early adopters of AI agentic development, trying to figure out how they produce good software. Dave invited me to share some of the early conclusions from the research on this channel in the form of practical tips. And the first tip, which I think will have the biggest impact on people's work, is to apply meta-automation. Meta-automation is critical for getting AI agents to perform like good engineers. It is the second-order process automation. It's automating how something gets automated. For example, an agent creating software code is the first level of automation. Automating how the agent is automated is the second level. In this specific case, I'm talking about meta-automation as a way of figuring out how do we automate how agents get feedback about their own work. An absolutely critical aspect of using agents for any kind of non-trivial software development is to get them to produce code the way you like it to be produced, consistent with your team's policies and rules. There are lots of ways how to do that, and lots of suggestions online, and some of it unfortunately looks like more like witchcraft and chance than proper engineering. The current online wisdom mostly suggests defining guidelines for agents using Markdown files. Some agent frameworks call these files skills, some rules, some constitutions, and this is potentially a good start, but it's incomplete. That's why there's a lot of additional advice online on what to do when agents blatantly ignore those guidelines, usually involving specialist agents that act as reviewers or coordinators, double-checking the work of primary agents. This tends to replicate the mental model of human teams for no good reason at all. It does reduce the problem a bit, but it doesn't solve it, because the reviewer agents also occasionally show up for work drunk. And then you need another level to review your reviewers. This is where the whole cycle starts repeating, and it just adds another level of complexity to an already complex process, hoping that it will somehow stabilize. The conspiracy theorists will say that this is all intentional and that this is a way for AI model companies to get you to spend more tokens on the same task because they keep tracking their KPIs based on engagement. I don't think so, but I do think that this is the wrong approach. Adding more agents to review other agents is like praying harder, it's just not good engineering. The right way to solve this is with meta-automation. For example, I'm currently working on a project where we have some specific runtime class representing the environment. There's a browser implementation of it, there's a Node.js implementation of it, and a runtime instance will get injected into other classes that need to make network calls. This allows us to run the same code in the front end and the back end. It also allows us to deal with some very important concerns like network retries, auditing, and security policies in one place. Nothing else should be making network calls directly. This is a very, very important rule. Since we started using agents to assist with coding, we tried describing this rule in many different ways. Yet occasionally, agents would still inject some network calling code somewhere directly. The funny thing about this is that most of the time it will be okay, and when you're reviewing a lot of code, these subtle mistakes can slip through, unless you're doing it very, very detailed. And there are a ton of these small context-specific rules like that. Tiny things like that require people to spend a lot of time reading code that the agents produced, then they require sending the agents back to go and fix their own work, then they require another cycle of review, just slowing down the whole process. These rules are all contextual, they're domain-specific, they're not like the tabs or spaces indentation rules that can be easily checked by standard linting tools. But they don't have to stay like that. From the early results of the research I'm conducting with teams, I can see that one of the most important patterns of getting big benefits from agents is to find ways to incorporate contextual feedback like this into deterministic tools, independent from agents. For example, we use ESLint for JavaScript linting, and if I knew how to write custom linting rules, I probably could write a rule that detects all the different types of network calls and restricts only the runtime class using fetch or XML HTTP request. I started to read up on how to do these things, and then I thought that, well, my AI intern can probably do that research faster. So I just asked Claude Code to design a rule that would detect those kinds of violations. It did that without breaking a sweat. I didn't trust it, but then I asked it to go and write unit tests for the linting rules using the standard ESLint rule testing framework. And it threw down a couple of examples that looked pretty good. Then I ran the linting tool on the whole code base. It detected a few places where we missed it despite the detailed reviews. Some of those were recently written by agents, but one was actually written by a human a long time ago, and we never detected it. It was a sobering experience. By getting an agent to automate how it checks its own output, we are automating the process of automation, and it scales beautifully. Instead of filling up the project constitution with random Markdown prayers, we have deterministic checks executed as part of the build process. We now have a bunch of custom rules with proper unit tests for the rules themselves so we can review them. We even have some custom tools written for checking aspects where existing linting tools were not applicable. For example, we use a tool built through an agent to check the static HTML code and make sure that it complies with our content security policies before deployment. This saves an amazing amount of time in review, and it prevents us from making stupid mistakes. The agents can run all these checks deterministically as part of their own process before it even comes to a human to check. There's no need to run specialist reviewer agents, no need to keep complex project-specific rules in Markdown files, and if the agents somehow decide to skip the checks, the rules will still be validated as part of our build pipeline, separate from any agentic work. This also means that fewer things are put into the agentic context, so agents can get more work done in the same loop.
We're extremely fortunate to be sponsored by EqualExperts, Transfic, and Octopus Deploy. Transfic is a financial technology company applying advanced continuous delivery techniques to deliver low latency trade routing services to some of the biggest financial institutions in the world. All of these companies, though, offer products and services that are very well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, do click on the links in the description below and check them out.
Finally, the nice thing about this is deterministic rules that we can use separately from agents allow us to switch AI agents in the future without worrying about them using the same syntax for rules, or even stop using an AI agent completely, but keep the same project consistency properly checked. So, here's how you can do this practically. First, I'm not saying that Markdown rules are useless. That's really important. Markdown rules are a perfectly fine starting point. They're easy to write, they're easy to iterate on, but once they stabilize, you do want to get proper engineering on it and move them from a Markdown prayer to something that's more deterministic. If you have rule files, read through them and think about this. If you had an infinite amount of time and money available, could you write a custom deterministic tool to enforce them? For rules where the answer is yes, well, ask your AI intern to automate the rule checking. It can use an existing tool, it can write a new tool, it can do something with static analysis or write a new command line completely. So make sure to ask the agent to properly test it and to write proper tests with examples so you can validate that the rules work exactly the way you want them, and test them once manually. Once that's done, you can pretty much believe these deterministic checks. They're not going to change. The key to make this work is to make sure that the error messages provide concrete actionable advice how to get back on track. This was one of the biggest lessons for me individually. A human can very easily work with a simple error message, but agents can get stuck in horrible loops when they don't know how to salvage themselves. The error message should explain what went wrong, but it should also provide a direction on how to fix it. Maybe even provide an example of how things should look like. This is absolutely critical to avoid wasting a lot of time or you having to jump in and salvage the agents. For example, instead of just saying, don't make network calls directly, also add, like, use hexagonal architecture to insert an instance of runtime class, then make these calls through the dependency instead. This helps to get the agent back on track without you having to figure out what went wrong, without you having to help them. If you keep repeating the same comments in your reviews, that's also an interesting point to think about. Well, maybe we should define a rule, maybe we should get an agent to automate these kind of checks as well. Of course, this kind of automation isn't new. With enough time and money, it was available to everybody, but the enough statement is the problematic point there. Most organizations did not have the capacity to keep writing and maintaining custom context-specific rules and tests. Instead, the project context was usually in people's heads, Word documents, or wikis. Senior developers communicated this implicit knowledge to juniors while pairing together and in code reviews, usually taking months and months to completely onboard people. Only the organizations with really dedicated developer platform teams were able to codify and maintain such context tools, and even then, those were not like team specific, they're more org specific. But today, with agents being able to produce code quickly, the cost of creating and maintaining such custom meta automation is almost zero. Process improvements that were only feasible to large organizations are now available to one-person teams. Instead of putting hope in Markdown prayers, use meta automation, apply proper engineering to your process. You will save a ton of time working with agents, and this also helps new team members, human team members, onboard onto new code bases more effectively. I will be back with more suggestions from the research soon, so subscribe to this channel to keep up to date if this was useful. By the way, if you are coding with agents, I would really appreciate it if you could fill in a quick survey about your process and help us validate the patterns from the ongoing research. It doesn't really matter if you're an expert or just starting. You will help us check the ideas that we're identifying on a smaller set and see if they actually apply to a larger context. As a result, we can produce better guidelines for the whole community, helping you and other people work with agents more effectively. As a way of compensating you for your time, for filling in the survey, I will send you the final aggregated results, and a way to score yourself compared to other teams with some concrete suggestions how to take the next step to improve your own process. To participate, just scan the QR code here or check the survey link in the comments below this video. Thank you.